Okay, hi everyone. So in this video, we will be looking at the 2012 H2 Math Paper 2, question 5, which is on probability, the first stats question in this paper. So the probability that a hospital patient has a particular disease is 0.001. A test for the disease has probability P of giving a positive result when the patient has the disease, and equal probability of P of giving a negative result when the patient does not have the disease. Given that P is 0.995, find the probability that the result is positive. So this is actually one of the easier questions in this paper. Before we do the question, it will be helpful if you can draw this tree diagram out for you to have an overall view of what is going on in this question. So for someone who is taking the test, he either has disease or he has no disease. So this is 0.001. This is 0.999. And for someone who has disease, he can be tested positive or negative. Similarly, for someone who has no disease, he has a chance of being tested positive and negative. So this is P, this is 1 minus P. P, 1 minus P. Given that P is 0.995, we are supposed to find the probability that the test is positive. So probability, the result is positive. We have two events for this, two possible events that leads to the result being positive. So the first possibility is the patient has disease and is tested positive, which is very likely if he has the disease already, okay? Or the patient has no disease, but for whatever reason, he is also being given a positive result. So probability that he has disease and positive, it will be 0.001 times P. Negative and okay, no disease and yet positive, so it's 0.999 times 0.005. This will give us 0.0059923 SM. Okay. Then for part IB, the patient has the disease given that the result is positive. So this is a conditional probability question because that's the word given. All right, they give you information, they ask you the question. Probability that the patient has disease given that the test is positive. So for the numerator, if you guys recall, it's A intersect B. So in this case, I want events that satisfy both criteria of the patient having disease and is being tested positive over the given condition, which is positive. Okay, so has disease and positive, it is 0.001 times P. Probability that someone is being tested positive, this is the answer in part I. So you have 0.1661. So if you round off, it is 0.16623 SM. Okay, part 2, it is given instead that there is a probability of 0.75 that the patient has a disease, given that the result is positive. So find the value of P. So they are telling us that probability someone has disease given that he is tested positive is 0.75. Okay, so in the numerator, like I said, you need events that satisfy both criteria, has disease and positive, over probability that the result is positive is 0.75. So if you write this in terms of p, according to the tree diagram, it is 0.001 times p over 0.001 times p plus 0.999 times 1 minus p. You want this to be equals to 0.75. So you can use GC to solve from this step onwards, but for those of you who prefer to simplify first, you will get 0.001p equals to 0.75 times 0.999 minus 0.998p. Okay, so I'm shifting the denominator over to the right hand side and simplifying that in the process. So this is equals to 0.74925 minus 0.7485p. So simplifying, bring all the p's to one side. And then you can solve for p. But remember, give your answer to 6dp as requested by the question. The reason why they ask you to give your answer to 6dp is because if you round off to 3SF or 4SF, 2SF or 3SF, your answer will be 1.00. Okay, which gives people the false impression that this is definitely happening, which is not true. This event is very likely to happen, but it is not 100% certain. Okay. So this is how we do question 5. In the next video, we will look at question 6, which is on hypothesis testing. So I see you guys in the next video.